In the world around us, mixtures are everywhere. From the morning coffee we brew to the power fueling our cars. Mixtures plays a vital role in our daily lives. But what happens when a mixture is constantly flowing in and out of the system? This is where differential equation comes into play.
Differential equations are mathematical tools that describe how things change over time. In the case of mixture flows, the differential equations allow us to model the concentration of a substance in a mixture as it is constantly being added to and removed from a system.
The concentration of a substance inside the container, which we denote as dm over dt, is equal to the input rate minus the output rate, where both input and output rate are solved by multiplying the concentration and its flow rate. We also need to remember that the concentration of the output rate is dependent to that of the input rate. This is because the concentration of the input rate gets mixed with the substance inside the container. Hence, constantly changes the concentration that comes out of it with respect to time.
A tank contains 400 liters of brine holding 100 kilograms of salt in solution. Water containing 125 grams of salt per liter flows into the tank at the rate of 12 liters per minute, and the mixture keeps uniform by stirring. Flows out at the same rate. Find the amount of salt at the end of 90 minutes.
For the problem number 1, a tank contains 400 liters of brine containing 100 kilograms of salt in solution. So, nasiya 100 kilograms of salt na dissolve siya sa tubig. So, maporma siya 400 liter. So, bali ang rin salt, natunaw siya ang masagol siya sa 400 liter. Next step is to draw and understand the diagram. So, we have a diagram that shows the problem. There's a rate of water flows into the tank, and there's a rate of water coming out of the tank. Write the formula. The formula is dm over dt is equal to Rn minus Rout. Step 4. Solve for the Rn and Rout. So to solve the Rn, we need first to convert some units to make it the same. Here, it shows that it is in terms of grams, but the problem, there's a kilogram, so we need to make it the same. So we need to convert 125 grams, 1 kilogram, 1,000 grams, equals to 0.125 kilogram. Tapos, next, we need to find the Rn. The Rn is equals to 0.125 kilogram per liter times the rate 12 liter per minute. So the Rn will be kilogram per minute, because the liter will be cancelled. 0.125 times 12 is equals to 1.5 kilogram. Now this is the Rn. Next is the Rout. To solve the Rout, it states that they have the same rate, the in and out. So it is also 12 kilogram per minute. And the tank has already 400 liters of solution. But we don't know the amount of salt because there will be coming from the outside in. over 400. As you can see, our solution is the same with the Rn. We have kilogram per liter of liter per minute, and the M will stand for the kilogram, the salt, and the 400 will be liter. So the liter will be cancelled. The 12 times 1 over 400 is equals to 0.03 kilogram per minute. Now we get the Rn and the Ro. Now substitute it to the formula and form the general equation for the first order linear dt. So the formula is dm over dt is equals to Rn minus Ro. dm over dt is equals to, the Rn is 1.5 kilogram. How will that put the unit? Minus Rout. The Rout is 0.03 M. We forget the M actually. M. And transpose the Rout to make it linear, first order linear dm over dt plus 0.03 m is equals to 1.5. Now we have a general equation. Solve the general equation to get the general solution. The formula for the linear first order linear DE is 1 So this is the basic general equation for the first order linear DE. Now we will use it to solve the Q. The y will represent as m, and the phi as the formula of e raised to integral of p of x dx. The x will represent as t, so replace t dt. You get the phi e raised to integral of pt. The pt will be the 0.03, and the qt is 1.5. So we will put them in a formula for the first order linear DE. So the pt is 0.03 dt. Integral for the 0.03 is 0.03 t. So this is the phi. We get the phi and substitute it in the formula. M e raised to V 0.03t is equals to integral of V of Q 1.5 times V e raised to 0.03 t dt plus C. So this is the basic formula to get the M. So this will be the formula. We will next integrate the inside. M e 0.03 is equals to, take the 1.5 outside because it's constant. Integration of 0.03t dt. Integration for e raised to 0.03t is copy the 0.03t times 0.1 over 0.03. This is the integration of e raised to 0.03t. Next, we will substitute it in the formula. M e raised to 0.03 t is equals to 1.5 times e raised to 0.03 t times 1 over 0.03. One 1.5 divided by 0.03 is equals to 50. 50 times e raised to 0.03 t plus c. Now, this will be the equation that we will be using for substituting the values. So, Q in M is equals to 100 kg. 100 kg because the tank is already filled with 100 kg of salt at time of 0 time. Substitute the given values in the equation. M is equals to 100 kg times e raised to 0.03 times 0 is equals to 50 times e raised to 0.03 times 0 plus c. Now we will solve it to get the c or the constant. E raised to 0, 0.03 times 0 equals to 0. So it will make us 1. E raised to 0 equals to 1. 50 times e raised to 0, 1 plus c. 100 is equals to 50 plus c. Transpose the 50 to the other side. C will be 50. Now we get the constant. Next is to substitute it on the next values. At M is equals to Q. At M, find the M. The M is the missing. Time 90 minutes. The problem say that find the amount of salt at the end of 90 minutes. So we will find the amount of salt in this time. Substitute the constant and the time to get the amount of salt. The amount of salt is times E raised to 0.03 T times the time is 90 minutes is equals to 50 times E raised to 0.03 times 90 minutes plus the constant is 50. So E raised to 0.03 A raised to 0.03 times 90 is equals to 14.8797 is equals to 50 times 0.03 times 90. A raised to 0.03 times 90 is equals to 14.8797 plus 50. 14.8797. 50 times 14.8797 is equals to 740.985 plus 50. 740.985 plus 50 is equals to 793.985. 14.8797. Divide both sides by 14.8797 to get the N. N will be 53.36 kilogram. And that's the answer.
So here is our solution to problem number 2. First, we identify our Ri, C sub I, R sub O, and C sub O. Based on the problem, R sub I is equals to 4 liters per minute. And our R sub O is equals to R sub I, which is also 4 liters per minute. Our concentration in the entrance is equals to 1 gram per liter, and our concentration in the exit is equals to F over B. So we solve for B, because this B is unknown. So for solving for B, we take our initial volume, which is 100 liters, our rate R sub I, which is 4, minus the R sub on the exit, which is 4 times the time. So B is equals to, just do some algebra. B is equals to 100 liters, which we will substitute here. So B is now equals to 100. So we will here our formula for getting M, to find M, which is this. dm over dt, the formula is dm over dt is equals to r sub I, c sub I minus r sub o, c sub o. We substitute our values this year. We do some simple algebra leading to this. Now we integrate. The integral of dm over m minus 100 is equals to ln m minus 100, and the integral of dt over negative 25 is equals to negative t over 25. We will raise this with the e so that we can cancel this. It becomes m minus 100 is equals to e negative t over 25 plus c. We use the simple properties of e, which is if this is here is a plus, it can be written as e negative t over 25 times e to c. And this here will be c only. Simplify this because a constant raised to a constant is also a constant. So m minus 100, we put the constant on the front, we copy this, which is e raised to negative t over 25, and our m is equals to c over c e raised to negative t over 25 plus 100.
Differential equation may seem daunting at first, but with a bit of practice, they can become a powerful tool for understanding and predicting the behavior of mixture in the real world. So, the next time you sip your coffee or fill up your gas tank, remember that differential equations are playing a role behind the scene, ensuring that this mixture just the way you like them. Differential equation may seem in our daily lives, but what happens when a mixture is constantly flowing in and out of the system?